Okay, you guys, the second line of evidence of evolution is known as embryology. Embryos are a stage of development before an organism is actually born living independently. And so one of these embryos, A through F, actually is an embryo of a human. So you once looked like one of these embryos. In this activity, you are going to predict. You do not have to be correct here. You are going to predict. You're going to guess which one is which. I really miss not being able to do this activity in class because this is one of my favorite activities that I do with you guys, because I think when we look at fossil evidence, there's so many missing pieces. But with embryology and looking at the relatedness and how close and how similar these embryos are, even looking at these, if I showed these independent of each other, I would have a very, very difficult time at this stage of development distinguishing one from the other. And so when you show them together, you can see these slight differences, but you can also see such great similarity. And so one of these embryos is of a human, one is of a rabbit, a fish, a salamander, a tortoise or a turtle, and a chicken, so it would be a bird. So go ahead and hypothesize. You're guessing. You do not have to be correct. And fill in A through F. Then go ahead and answer the questions. Go ahead and answer the question. Look again at the 6 embryos in their earliest stage. So these are the earliest stage that I'm going to show you. Describe the patterns you see. What physical similarities exist between each of these embryos? And so you clearly can see a tail. Oh my gosh, you guys once had a tail. You did. You can clearly see the head region. You can see in this region right here, these are going to be pharyngeal pouches. They're things that will eventually become either maybe the lungs or the gills, depending on what the organism is. And so look for similarities. Once you are done with that, then you're going to move on. I want you to pause this video. I want you to go and fill in these answers and then come back and rewatch the video. Okay, now you go to the next page, and these are the same 6 embryos, but these are older, little bit more developed embryos of the same organisms. They just have been able to continue to grow, develop, and differentiate. And so now, looking at them, go ahead and check again. Don't go back and change your first ones, but go ahead and are you able to indicate what's what when you look at these little bit more developed embryos? And so go ahead, again, you're predicting, you do not have to be correct. Go ahead and predict which one do you think is the human, the rabbit, the fish, the salamander, the tortoise, and the chicken. Look again at the 6 embryos in their older stage. Describe the patterns that you're seeing here, because you're definitely seeing some distinction. I would say C, D, E, and F, you still see a lot of similarity. A and B, you actually see more similarity. And so that might be an indication that A and B actually might be more closely related than A is with D. Go ahead and also answer question 3. What physical differences are becoming visible between the embryos? You can really see some physical differences in A and B. They're elongating, they're stretching out, different things like that. So go ahead and answer those, and then come back to the video and we'll move on to these embryos in their most advanced stage, shortly before they're actually born. So pause the video, answer the questions, and then come on back. All right, here are those same 6 embryos right before these organisms would start living independent on their own, getting their own energy, doing their own characteristics of life. And so you can see they're labeled now. We have the fish, the salamander, the tortoise, and the chicken. Notice those have some pretty great similarities. I'm sure you probably have heard that birds evolved from dinosaurs. Dinosaurs are reptiles, so are tortoises. And then you have the rabbit and the human, both actually of which are mammals, and so are much more closely related than the human is to any of the other organisms. And so go ahead and fill out this little chart. It gives you the species, and then just identify the anatomical. Those are the anatomy, things that you see, changes from early to late stages. So you don't have to identify all of them, maybe list 1 or 2 for each of the organisms. Then look again at the 6 embryos in the earliest stage, and then the older stage, and the most advanced stage. So kind of go from the earliest to the oldest. Don't go back and change your prediction. It's totally fine that they weren't completely correct. Do you think that this suggests, though, looking at how similar they were at those early stages, and then they continue to develop, think about if their body plan was written instructions in their DNA. Do you think they have some pretty good similarities in DNA, which is going to be that molecular part? Because that's the plan, and they started off very, very similar to each other. And so question number 4 just asks you to look again through all those and identify if you think that this could support some evolutionary relationship, meaning, do these organisms maybe share a common ancestor? Do they have similarities that would indicate they could have came from a similar prehistoric organism? And which ones are more closely related than others? Explain how these embryos can be used as evidence of common ancestry or relatedness between these 6 groups of organisms. And then number 5, based on the embryos, which organism is most closely related to the chicken or to the bird? What is your reasoning? So go ahead and go back here and just look at these. Here we have the chicken. Which one of these is most closely related to the chicken based on these embryos? And why do you think that?